All right, you're welcome to the class again today, and we are so excited to have you in this class today as we're going to be talking about waves. And we define waves as what disturbance that travels through a material medium, transferring energy from one point to the other in the medium without causing any permanent displacement to the material or the molecule particles of the medium. So wave is a disturbance, travels through a material medium, transferring energy from one point to the other in the medium without causing permanent displacement to the particle or energy or materials of the medium. Now we have 5 characteristics or properties of a wave. 5 key properties of wave that I don't want you to forget. We're going to be looking at each of the properties elaborately in another class. But the first property is reflection. Oh my God, wave can reflect. Reflection. For example, if you stand before mirror, you see the reflection of yourself. That's reflection of wave, okay? When you make a sound and it hit the wall and come back to you as an echo, that is reflection of a wave. That is sending back of a wave or the ray of a wave or wave energy when it hits an obstacle. That is reflection. The next one is refraction. Oh, go. Refraction. What is refraction? Refraction happens when a wave energy lands at the surface between two medium of different density. A wave can land on the surface between two medium of different density. By virtue of diagram, reflection looks like this. This is a surface, right? The wave hits and go back. This is called normal. This is incident ray. This is reflected ray for light, right? Incident ray, reflected ray, R. And this is angle of incident and angle of refraction. R, the I, angle of incident, R, angle of reflection. All right, for refraction, it comes into a medium of different density, density 2, density 1, and a wave is coming in, it gets to this place, then get refracted. That is the bending away. There's a bend. Instead of it to travel straight as it's coming, because of the different density, this is our incident ray, this is our refracted ray, and this is angle of incidence, this is angle of refraction. All right, so change in direction of a wave when it comes in between two medium at the junction of two medium of different density, that is what? Refraction. Okay, let's go straight to the third property of a wave. The third property of a wave is interference. Oh my goodness, what is interference? Interference is just simply what happens when two waves who are traveling in the same direction, opposite direction, comes together. When they jam heads together, all right, let me use that word. When there's an interference between two or more waves that are traveling in the same direction or in different directions, that is called interference. And under interference, we can have a constructive interference in which the wave become reinvigorated because two waves are coming together. If it's a constructive interference, it becomes strengthened. And we have destructive interference where when the two waves come together, they neutralize each other. You see, under constructive interference, you have two waves coming like this, bam, 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 and this wave coming like this, and they meet here. Constructive, they will now have a higher wave. All right, that is constructive interference. Under destructive interference, wave 1 is coming and wave 2 is coming, and they form something like this. This is a form of destructive interference. The wave can cancel out. That is destructive interference. All right, let's go to the fourth property of a wave. All right, the fourth property of wave is diffraction. What is diffraction? Diffraction is what happens to a wave when it's coming and come through an obstacle with a narrow opening for it to escape. It diffracts. For example, a wave is coming like this, sound wave, and it comes through an obstacle. Now notice that the wave is coming like this. Once it hits this obstacle, there's possibility for the wave to now change its wave pattern this way. You know, so that is diffraction. So ability of a wave to go through a narrow obstacle and form a different thing. So when it passed through the obstacles, it behaved differently at the end of the obstacle. That is diffraction. The last property, but not the least, is what? Polarization. All right. Polarization is the fifth properties of a wave that I want to talk about. What is polarization? Polarization is reduction in intensity of a wave when it passes through an object called a polaroid. Let's give an example. Light wave shines this way. When you see light shining, it shines in all directions. When you put a polaroid in front, this is a polaroid. This polaroid will only allow the rays of light that travel in its direction to pass through. So the ray that is coming travels in all directions. This is unpolarized light. Why this is polarized? So this is a polaroid. A fuller class, a more comprehensive class on polarization will be conducted. But just know that there are 5 key properties of wave: reflection, refraction, interference, diffraction, and polarization. And I think with this class, you have an introduction or a refresher on the properties of wave, which can be a positive influence or impact on what you know about wave and can help you succeed in your endeavor. Make sure you do what? Share this class, subscribe to this channel, and if you have any question, leave it in the comment section. Make sure you are good. Hasta la vista. Bye bye. Love you.